All right, hello everyone. This video is the beginning of a series where I go over all of the problems, all of the practice problems on the ETS website. We will have many series like these where we discuss official ETS practice problems. This one is just about the website, so follow along with me. You can click on the link in the description, or you can just follow along. I'm going to share a screen now. And we're going to start with the quant comparison problems. That's obviously a quantitative type. In the GRE, quant comparison problems are very popular. In fact, it's the most common way of asking a question in the quantitative section. So it's very important you get used to these. Basically, you're given two quantities, quantity A and quantity B, and you have to answer which one is greater. So answer A means A is greater, answer B means B is greater, C means they are the same, and D means it's impossible to know. So D does not mean you don't know, it just means from the information given, it is impossible to know the answer. So let's just walk through them now. Quantity A, it says the least prime number greater than 24, and quantity B is the greatest prime number less than 29. So in the GRE, it's important to obviously know prime numbers. Prime numbers are any numbers that cannot be divided by any other number except itself or 1. So, for example, 2, 3, 5, these are all prime numbers. The bigger they are, the harder they are to find, but it's probably useful to memorize the first, all the prime numbers like before 50. The smallest prime number after 24, I'll give you a moment to think about, you can pause it if you want, is 29. Now, we're comparing that to quantity B. Quantity B is the greatest number, or the greatest prime number, below 28. If we already know that quantity A is 29, do we really have to know what the the greatest prime number below 28 is? Remember, the question is asking, is quantity A greater or quantity B greater? We already know that quantity A is 29, and quantity B is something less than 28. So, as you can probably guess, A is going to be greater in any case. And of course, the prime number below 28 is 23 here. So yeah, good job. Let's keep going. So we have Lionel is younger than Maria. Quantity A is double the age of Lionel. Quantity B is Maria's age. So here we have no exact numbers for A and B, which is different than the first answer or the first question we did. What do you think you should do? You might just start picking ages and seeing if quantity A is greater than quantity B. And anytime you should pick numbers, I would suggest picking the absolute easiest numbers first. So what is the easiest numbers, the easiest ages that Lionel and Maria can be? If Lionel has to be younger than Maria, then maybe I'll say Lionel is 1 and Maria is 2. Those are the easiest. Quantity A is twice Lionel's age. What would that be? 2, obviously. Maria is 2. So in that case, we would have C as our answer, C meaning the two quantities are equal. Could you think of another pair of ages where Lionel is still younger than Maria, such that we have a different answer, aside from C? Well, you could say Lionel is 1 and Maria is 3. If Lionel is 1, then twice his age is 2. And if Maria is 3, then of course quantity B would have to be greater because 3 is greater than 2. So now we've proven that there are two possible scenarios. One scenario where they're equal and another scenario where B is greater. Anytime you have conflicting results, meaning one situation that conflicts with another one, either an A, B, or C scenario, then you choose D as your final answer. because basically you've proven that there's overlap, and you've proven that there's more than one scenario that could be the answer. That's when you choose D, and that would be the right answer here. So the lesson from this problem, though, is you should always pick the easiest numbers first and then move on from there when using the picking numbers strategy. All right, let's try this next one. Quantity B is 54% of 360. Sorry, quantity A. And quantity B is 150. What would you do here? Well, B is already decided for us, so let's just solve for A. If I wanted 50% of something, I would multiply it by 0.5 in the calculator. If I wanted 54% of something, I would multiply it by 0.54 in the calculator. To get 54% of 360, you just put 0.54 times 360 in the calculator. Okay. There is a quick way to do this. If you understand that 150 is half of 300, then you can automatically know that A is greater. Why? Because A is more than half, 54%, of more than 360. Well, more than half of 360 has got to be more than 150 because half of 300 is 150. So oftentimes in the GRE, there are quick ways to answer problems. This is one case. Another case here would be, using simple numbers. And in the first one, even, you didn't have to solve for B. That happens a lot in the GRE. Sometimes you don't have to solve for quantity A or B. One of the two you don't have to solve for because you can automatically know, using logic, that one is greater than the other. All right, let's keep going. Number 4. Number 4, we have a triangle. It says PQ is equal to PR. When they have like this notation, it means the distance between point P and point Q. And the distance between point Q and point R, they're equal, it says. Well, if they're equal, then does that tell us much about the distance between P and S and the distance between S and R? That's quantity A is this distance here, and quantity B is this distance here. No, it doesn't give us any information about these two lines. And that's why you just choose D. There's another lesson to be learned from this problem, and that is you cannot trust your eyes in geometry problems. In the GRE, they like to make things look a certain way, but you will still have to prove it mathematically that it is that way. It looks like PQ and PR are the same. PS and SR are the same, but there's no way of knowing. And they illustrate it below. See, they see that this line could go to the left or could go to the right, which would make this, these different, these distances. So let's try out the next one. It says, well, now we have an equation. Y equals 2x squared plus 7x minus 3. We have an x value and a y value. So what do you think you should do here? What do you think is the best option? If you guessed picking number strategy, then you'd be correct. So let's think about this. If we had to pick numbers and solve for the other variable, which variable should we pick numbers for and solve for the other one? Which one would be easier? It would definitely be the y variable. I'm sorry, it would definitely be the x variable, because if you solve for the x, the y is alone. If you were to solve for the y, or sorry, if you were to plug in a variable for the y, solving for the x would not be easy because you have an x squared and an x. Let's think, what again are the simplest, sorry, I just gave it away. What type of numbers should you plug in? That's right, the simplest numbers first. So if I plugged in 0 for x, what would y be? Well, 0 squared times 2 plus 7x is obviously 0 minus 3. So 0 plus 0 minus 3. That would be negative 3. Y would be negative 3 in that case. So if x were 0, then y is negative 3. Well, that would make a greater in that case. Let's keep going. What other numbers could you plug in? If you said 1, then good job. It's another easy number, and it might give us another answer. So let's see. 2 times 1 squared is 2. Plus 7 times 1 is 7. So 2 plus 7 is 9. Minus 3 is 6. Y would equal 6 when x is 1. Well, in that case, b would be greater because y is 6. B is 6. A is 1. X is 1. And what answer do we pick when we have conflicting results? In one case, we had a is greater. The other case, b is greater. Yes, we picked D. There you go. D is the answer. Okay, let's keep going. Now we have a slightly more complicated problem. It'd be a little bit annoying to pick numbers here automatically. You could pick 5, 6, 7, 8 and put that in here and compare it to 5, 6, or 7, or 8. You could do that. Or you could simplify it first. Now remember, this is almost an algebraic expression, but we just don't know what's in the center. What I mean is quantity A could be equal to quantity B. Quantity A could be greater than quantity B. Quantity A could be less than quantity B. In any case, you can do algebraic manipulation. All the same. Except multiplying or dividing by a negative number, but we can talk about that later. You don't have to do that here. So if we do the same to both sides to simplify it, we would end up multiplying both sides by 5 to get rid of this denominator. This would leave us with 3y plus 2 equals or is less than or greater than 5y. We could get rid of the 3y over here by subtracting it. That would leave us with 2 is less than, greater than, or equal to 2y. Divide everything by 2, and you get 1 is less than or greater than or equal to just y. Then you could plug in numbers. Obviously, if y is greater than 4, and you're just comparing 1 to y, no matter if it's 5, 6, 7, or 8, it will always be greater than 1. And they've done that here. You could, however, immediately, if you did not have the wherewithal to start simplifying it, you could just plug in 5, 6, 7, 8 here, and you're going to always get that b is greater no matter what. So that's nice to know, though. Okay, let's keep going. This one is a little bit difficult. We have exponents, all with the same base of 2. Quantity A is 2 to the 30th power minus 2 to the 29th power over 2. Quantity B is 2 to the 28th power. Now, just like before, you could start off by simplifying. We could get rid of this numerator. Or sorry, denominator. You could multiply both sides by 2. If you multiplied the left side by 2, obviously you'd be getting rid of the division. You would be left with 2 to the 30 minus 2 to the 29. If you multiply 2 to the 28 times 2, 2 to the 28 is essentially 28 2s written in a row multiplied by each other. If you add another one on the end, this is just 2 to the 29. So this is 2 to the 30 minus 2 to the 29 on quantity A, and then we're comparing it to 2 to the 29 on quantity B. I think they do that. Yes, they do that here. Now, 2 to the 30 minus 2 to the 29 can be simplified. And this is really an important pattern to catch because it's very common in the GRE, and it's almost, it's always the same. You can't do much else with this. So basically, if you factor out one of the 2's in 2 to the 30, remember how we kind of factored in a 2 here? We added a 2 and it made the exponent 1 greater. If you extract one of the 2's, you could say that 2 to the 30 is equal to 2 to the 29 times 2. 2 times 2 to the 29 is obviously 30 2's in a row, but you're taking one of the 2's out of the exponent. So it's like 2 to the 1 times 2 to the 29. But if you notice now, we have 2 to the 29's minus a 2 to the 29. You could think of it like algebra. Like 2x minus x is x. 2 of 2 to the 29's minus 1 of 2 to the 29's is going to be 2 to the 29. And we have 2 to the 29 on the right, as seen here. They equal each other. They do it a little bit differently. They just add the 2 to the 29 to the other side, to both sides, getting rid of it on the left and leaving it on the right. Now, 2 of 2 to the 29's is the same as saying 2 times 2 to the 29, which is the same as saying 2 to the 29 plus 2 to the 29. So essentially, they're equal to each other. You can go back, listen to it again if it was a little too fast. I know, you know, this video just goes over practice problems. It doesn't necessarily teach a lot of the exponent rules that we need to know. That'll be later, but good job keeping along, staying along with me. The answer is C. All right, let's keep going. Number 8, we've got quantity A is x squared plus 1, and quantity B is 2x minus 1. What's the easiest strategy you could use here? If you pick the picking number strategy, you'd be correct. What's the easiest number you could pick? 0. Well, 0 squared plus 1 is 1. 2 times 0 minus 1 is negative 1. In that case, A is greater. A is 1 and B is negative 1. Let's try using the number 1. What would be greater? That's right. A would be greater because A is 2, 1 plus 1, and B would be just 1, 2 minus 1. If you picked any negative number, any at all, which would be greater? If you said A, then you'd be right because a negative number multiplied by itself is always positive. So we know that this is always positive. 2 times a negative number is always negative. Minus another negative, of course, is negative. So that's interesting. That kind of allows you to not try any negative numbers and just automatically know that A is greater. So we have A is greater with 0, with 1, with any negative number. What we might pick next is kind of a big number to see if we get a change in a result. So maybe we'll try 10. 10 times 10 is 100, plus 1 is 101. And quantity B would not be that close. It would not be close at all. It'd be 20 minus 1, which is 19. So definitely A is greater in every case here. There you are, quantity A. Number 9, try the picking number strategy. It tells us that W has to be greater than 1. By the way, we chose negative numbers in the past because they did not give us any constraint about the value X. If they give you no constraints, you can pick whatever you want, but here's a constraint here. When W is 2, which is the first easiest number to pick, then quantity A is going to be 10, and quantity B is going to be 9, so A would be greater, right? If you picked 3, 4, 5, or 6, you're always going to get A is greater because A is growing by 7 every time, and B is only growing by 2 every time. Interesting. So why would the answer be D? The answer is D. It's because we are forgetting one type of number that we should be picking. It does not say that W has to be an integer. If you were to choose the minimum extreme, for example, like 1.1, then you would find that B is greater in that case. And this is an important lesson. If ever you have, if you have to use the picking number strategy, be wary of forgetting to use decimals or fractions. If it does not say that the variable has to be an integer, always remember to use a decimal or fraction. Okay? If you were to choose 2 or any integer above 2, you would always get A is greater in this case. And only if you understood that you can pick a decimal, then you would know that the answer is D. All right. Okay, that's the end of this part. So thank you for watching. Thank you for watching all the way to the end of the video. If you wanna help me out, please subscribe. And if you need help, please consider going to my website by clicking the link in the description, applyconfidently.com, to get some one-on-one tutoring with me. Just click the schedule free call button. And you can write when you schedule the call that you saw me on YouTube, and I'll give you a 10% discount. So have a good one and happy studying.